Hi everyone, how do you graph f of x equals x to the negative 1? What's another way of writing x to the negative 1? 1 over x. So what does this function do to its input or argument x? It takes its what? It takes its reciprocal. How do you graph the reciprocal function? What's the graph of y equals 1 over x? Okay. By the way, a reciprocal is also called a multiplicative inverse. When you multiply these together, you get 1, the multiplicative identity. But how do you graph y equals 1 over x? Let's do some point plotting. Now, first of all, what's the domain of this function? We should ask that early on. The domain is the set of all real numbers except what? Except 0. So you plug in 0, it's undefined. But we can plug in 1. The reciprocal of 1 is 1. The reciprocal of 10 is 1/10. The reciprocal of 100 is 1/100th. As x approaches infinity, if x goes to 1,000, 1,000,000, 1,000,000,000, these function values, these reciprocal values, they go to 1 over 1,000, 1 over 1,000,000, 1 over 1,000,000,000. They seem to be approaching 0 from above. That's why I have 0 plus here. So based on this point plotting, you might guess that this is a piece of the graph where the point 1, 1 is on the graph, and as x approaches infinity, the y coordinates, the function values, approach 0 from above. Notice that the x-axis is a line that the graph approaches in the long run. We call the x-axis an HA, or I do. What does HA stand for? It's a horizontal asymptote. In general, an asymptote is a line that a curve or graph approaches in either a long run or explosive sense. Here we're looking at things in a long run sense. The distance between the graph and the line approaches 0. We usually indicate asymptotes as dashed lines, although sometimes if the x-axis is an HA or if the y-axis is a VA, a vertical asymptote, some books don't bother. Okay, now, what about values of x strictly between 0 and 1? We know we have a problem when x equals 0. We won't get any points here. But what's happening as we travel from x equals 1 backwards towards x equals 0? What happens as x approaches 0 from the right? Now we're thinking calculus. It's like we're taking the limit of the function as x approaches 0 from the right. A table. Going from right to left. The reciprocal of 1 is 1 again. That's why 1, 1 is a point on the graph. I'm just reiterating that. But now the reciprocal of 1/10 is 10. The reciprocal of 1/100th is 100. The reciprocal of 1 over 1,000,000 is 1,000,000. So it appears that as x approaches 0 from the right, from greater numbers, the function values, the reciprocals, will be approaching infinity. In calculus, you might write something like this. 1 over x approaches infinity as x approaches 0 from the right, or from greater numbers. So then, you should agree that as we move from x equals 1 towards x equals 0 from the right, that the y-coordinates are approaching infinity. And then you might agree that the graph in quadrant 1 looks like this hook here. But it's an infinitely long hook. Now, in calculus, you are going to define asymptotes in terms of limits. So again, the y-axis is a vertical asymptote, or VA for the graph, because the function values themselves are approaching infinity as x approaches a number from the right or the left. Now, what happens if you replace x with its opposite? You get 1 over the opposite of x, or the opposite of 1 over x. This is the opposite of f of x. F of x is 1 over x. Right. The domain of the function is all real values except 0. That's set difference notation. So the domain is symmetric about 0. What am I getting at? This reciprocal function is what kind of function? It is odd, which means that the graph is symmetric about the what? It's symmetric about the origin, which means that we have this graph in quadrants 1 and what other quadrant? Quadrant 3, which makes sense because, for example, the reciprocal of 1 is positive 1, but the reciprocal of negative 1 is negative 1. So it makes sense that if xy is a point here, then opposite of x, opposite of y will be a point here. Reciprocals of negative numbers are themselves negative. And 0 has no real reciprocal. That's why we don't have any points on the y-axis. We do, however, have an HA at the x-axis and a VA at the y-axis. All right, that's the graph. You go to Desmos, y equals 1 over x. And if you remember your Algebra 2 class, this is a conic section. Which conic section is it? It's not a circle. It's not an ellipse. It's not a parabola. It's a hyperbola with the axes at the coordinate axes. Here are the axes. An HA at the x-axis, y equals 0, and a VA at the y-axis, given by x equals 0. These should be dashed, though. All right. Now, this is called a hyperbola. What other graphs will look similar to this guy here? Well, how about y equals x to the negative 3, for example? How can you rewrite x to the negative 3? As 1 over x cubed. And so forth. Y equals x to the negative 5th, or 1 over x to the 5th. All these guys are going to have these quadrant 1 and quadrant 3 type graphs with these as asymptotes. Okay, but they're not called hyperbolas. Okay, y equals 1 over x gives a hyperbola. These are not technically hyperbolas over here, but their graphs are somewhat similar. Y equals 1 over x cubed, for example, in red, that's flatter as we approach the x-axis out here, but it's steeper as we approach the y-axis. The values climb up faster. Okay, don't worry about that. Next up, how do you graph y equals x to the negative 2? Oh, by the way, on Desmos, let's do a comparison. Here's y equals 1 over x cubed. Okay, so that's in red versus the green graph. Again, the red graph approaches the x-axis more quickly, but not the y-axis, because these values are steeper over here.